Oh, I usually wait till recap starts if it's just started. So. Right, this week we're going to look at a case study incident that happened a number of decades ago. Has anybody heard of the Piper Alpha incident? Yeah, oh, good. It was an offshore rig. There it was there. There's a picture of it. Now, really what happened on this rig was dreadful. A lot of people lost their lives. And the idea is that we're going to show you a case study here, and we're going to have a look at some of the fundamental things in terms of safety that went wrong, because obviously they did. I mean, there's no getting away from it. It's a complete disaster. But the Piper Alpha is an offshore production platform operated by Occidental. Now, it started life as an oil platform in 1976, and then later it was actually converted to gas production. And there's a picture, it's a fairly typical looking thing with a helipad, and there's the drill equipment, the exhausts, all that sort of thing. Quite a big production platform. So a large fixed platform means it was bolted to the bottom of the sea, and it was situated on the Piper oil field, approximately 120 miles northeast of Aberdeen, in 474 feet of water, about 144 metres. So quite a way off, and in very, very deep water. It was part of an integrated set of platforms. As you can see there on the left, we've got the Claymore platform. There's Piper Alpha there, and it was connected to the Claymore and the Tartan, and they used to send their gas back and forwards, and then it would go to shoreside. It was also connected to the oil from when it was an oil production platform as well. So at 9:58 p.m. on the 6th of July 1988 was an explosion which occurred on the rig. It set off a chain of fires and explosions, and it resulted, well, it says there, near total destruction. It was total destruction of the installation. There was 226 people on board the rig. 165 were killed, and also 2 rescue workers lost their lives. So what happened? Well, that's really what we're going to look into today with the case study. So the accident started with an explosion in Module C, and this contained equipment to condense and pump LPG condensate. There was 2 pumps, Pump A and Pump B. Pump A had been handed over to it was due for maintenance, so they'd shut it down and they'd handed it over to the maintenance people. As a result, once it was shut down and they'd signed it off to the maintenance people, a delivery relief valve was actually removed at the same time so that they could overhaul it. Now, during the evening, the one they had running, Pump B, actually failed. Stopped, and they couldn't get it started again. So, without realising that the relief valve was missing, they thought Pump A's just been shut down for maintenance, nobody's touched it yet. That's got to go on again, because they needed this LPG pump to actually supply the power to the rig. So they lost power for any length of time, the whole rig would shut down, which would have meant a huge amount of loss to the actual platform. Now, they didn't realise the relief valve was missing, so whoever took the relief valve out hadn't really put a permit to work in, and they just put hand-tightening bolts on the flange where they took the valve out, and this really wasn't much to stop the gas from leaking once they started up Pump A. So basically what happened was that it started to leak and blew off, and of course all this liquefied gas blowing all over the place. It didn't take long to explode. Usually these things find the source of ignition and it exploded. And that's the initial incident which set things off. So like I said, the root cause was the failure of the permit to work system, and you'll see that in the film that I'm going to show you today. And this failed to prevent pump A being started up. There was a permit to work for the actual pump, but there was also a separate permit to work for the relief valve. And at some stage these didn't get together. So when they wanted to restart pump A, they just had a look at the permit to work for the actual pump itself. The one for the relief valve, it disappeared somewhere. So they started up, they shouldn't have done. Now that's the incident itself. Usually you find in situations like this, when there's an incident, there are other weaknesses in the system. And really Piper Alpha at this particular time demonstrated an awful lot of weaknesses in the system. The permit to work system was a tick box system, and people after a while, the tick box systems start treating them with a bit of contempt. I don't know, I'll just tick that and do it, doesn't really matter. That was a problem in its own right. There were problems with the shut-off emergency facilities. There was poor communications, which exasperated the problem, and there weren't any proper emergency and rescue procedures. There was no clear line of command and responsibility once this incident started, which made it much, much worse than it needed to be. It was bad enough in the first place, but things really went from bad to worse very quickly. So here's another picture of the rig. As you can see, we've got various sections here. Section C was the gas compression. This is where the LPG pumps were. In this section here, anyway, the accommodation block was there, and there was a heli deck. And as you'll see in the film, once this explosion and fire took off, basically the smoke was blown in the wrong direction. There was no chance of helicopters landing on the heli deck and taking people off, and most people ended up trapped in the accommodation block. That's just to give you some idea of the way things were laid out in this. I'll take you back to the Swiss cheese model, which I showed you last week. Now, all safety consists of layers of protection, and these are these slices of cheese, if you like. And that stops hazards from becoming incidents or losses. And this layer of protection is, it can actually be actual mechanical items, such as safety equipment and things like that. But in a management structure, you've got individuals doing their jobs, keeping to their responsibilities. You've got line managers. You've even got the organisation's responsibility and attitude towards safety in there as well. And as you know, nothing's perfect. As soon as human beings get mixed into the mix, we are not 100% perfect. So there will be holes in each of these slices. That's the where the cheese model comes from, I think, Swiss cheese. And if you are unfortunate enough to have these lined up in a certain way that the defects are available at the same time, especially when there's a major incident happening, the hazards will happily go through all your layers of protection, and you will end up with a disaster on your hands. So management of process safety relies on many systems, layers of protection, and the risks increase and the incidents will occur if there are holes in the system. The bigger the holes, the better the chance these will line up. And that's when the incidents occur. So we're going to show the video. It goes on for about half an hour. So while you're watching the video, and I believe some years Sue Hale slips a question into the exam on this one. I don't know if she's going to do it this year, but it's worth mentioning. So while you're watching the video, I want you to have a look at various aspects of what goes on. You'll see in the video, it's fairly good. It goes through carefully the actual incident. I want you to look for risk awareness. How aware were people of the risks involved? design factors, what aspects of the design contributed to this kind of thing. I want you to look at the layers of protection in terms of hardware, which is equipment, and software, which is people and attitudes. Tolerance of defects. This is something you'll come across if you've worked in industry. Defects happen all the time. If you're intolerant of defects, you get them fixed straight away. Some people are far too tolerant of defects and they let them lie. If an incident happens and you've got things that are defective and you've let them lie for a few months, then they will come to play and happily bite you. That happens. That happened here as well. Human factors. Error. How people approach things, their attitude to safety. You'll see that sort of thing happening. And emergency preparedness as well. How prepared were they? Of course, nobody expects an emergency, but they do happen. Right, I'll show the video, and then we'll have time for a few more slides and a couple of questions if you've got them at the end.
No, the decision was made for me. It was motion. You know, it was fry it or jump, so it was jump. Miles from Aberdeen, beneath some of the fiercest waters in the North Sea, is the Piper oil field. The platform which exploited the field was gigantic. At its peak, it produced 30,000 tons of oil each day, worth £3.5 million. Its sheer size made it seem almost indestructible. But on the night of July the 6th, 1988, the unthinkable happened. In less than 3 hours, the Piper Alpha platform, standing 200 meters above the seabed, with 226 men on board, was reduced to this. The common image of the disaster is of a single devastating explosion. In fact, once it had begun, the catastrophe unfolded gradually. During one crucial hour, there were critical moments when it could have been averted. Owned by Occidental Petroleum, Piper Alpha was spectacularly productive. In June 1988, producing 10% of Britain's North Sea oil. It had been built in 1976, initially only to extract oil, but it was later adapted to produce gas as well. This left an unfortunate legacy in its design. The platform was made up of 4 modules, separated by fireproofed walls, arranged so that the most dangerous works, such as drilling, were as far from the accommodation block as possible. When Piper was belatedly fitted for gas extraction, some of the gas compression works had to be sited close to sensitive areas, such as the control room. This was to have tragic consequences. In the weeks leading up to July the 6th, a new gas pipeline was being installed, which involved welding work and changes to the normal operating routine. The platform was not shut down while work progressed. Several small gas leaks had been reported, though this was not unusual. On July the 6th, one other piece of work was going on. The platform had 2 large pumps, A and B, which pressurized the gas and sent it onto shore. Pump A had been taken out of service that morning and a pressure valve removed from it for servicing. The open pipe was temporarily sealed with a metal plate. The pressure valve was meant to be replaced by the end of the day, but the job overran.
Alright lads, pack it up. We're not running over here. We'll have to finish in the morning, I guess.
The engineer in charge filled out the permit to work form, which let everyone know that the pump was out of action and couldn't be used. In fact, 2 permits had been taken out that morning for the pump. One was for the work on the pressure valve, the other for a routine overhaul, which would last 2 weeks but hadn't yet begun. The 2 permits became separated. When work finished for the day, the engineer returned the permit for the pressure valve to the control room. Finding the supervisor busy, he signed off the permit to work. He failed to inform the supervisor that the valve was off the pump and went off shift. No one knows what became of the permit for the pressure valve.
The permit to work system on Piper had degraded. It hadn't been working well for many, many months. They weren't, in fact, thinking through in a proper way the risks of the process before they filled the permit in. Otherwise, a number of the things that occurred at the time couldn't possibly have occurred. And the whole thing was treated, it would appear, more or less as a formality.
Another irregular practice was taking place that evening. In common with other platforms, Piper Alpha had an automatic fire deluge system. When triggered, diesel pumps would suck up huge amounts of seawater to douse any fires. But when divers were at work, the diesel pumps were switched over from automatic to manual start to prevent any divers being sucked up by the intakes. On other rigs, the pumps were switched to manual only if the divers were very near the intakes. But on Piper, they were switched over regardless of where the divers were working, so the firefighting system could only be started by hand. At 9:45, the swift spiral to disaster began.
Phase 1 operator, over. We've got a trip on B pump. Better get down here and have a look at it, over.
The second gas pump, Pump B, which had not been taken out of service, had stopped. If it could not be restarted within minutes, the gas supply for the rig would have to be shut down. Since the platform was powered by gas-fueled generators, the danger was that it could lose all power. If drilling was going on, the drill could get stuck at enormous cost. The supervisor kept a watchful eye as Pump B repeatedly failed to restart.
Okay. Look, hold on a second. What's up?
Can't get it started.
How come?
I don't know. There's lube oil on the floor. Someone's talking about hydrates. Pump A's out for maintenance.
Right.
But it's a 2-week job. They only started it today. It's only been electrically isolated, I think. Where's the PTW for it?
The engineer retrieved the permit for the 2-week maintenance job on Pump A. He was not aware that there was a second permit for the work on the pressure valve, so he didn't know that it had been removed.
I'll sign it off. We'll get Pump A back on, we can use that one.
All right.
Maintenance, lead hand. Contact control room.
That one, give them the okay, and we're going to go straight away. All right.
Since the maintenance work hadn't yet started on Pump A, the supervisor assumed that it would be safe to restart. As Pump A was prepared for restarting, no one noticed that the vital pressure valve was missing, since the metal plate was 15 feet up and hidden by machinery.
Moved it yet? Come on! short of time here.
Just before 10 o'clock, the operators restarted pump A.
All right, give that a go.
That's on, zone 3. Maintenance lead hand, we've got a trip on two of the centrifugal compressors, over.
As gas flowed into the pump at high pressure, the strain became too much for the temporary metal plate. With 70 kilograms of gas escaping in under 30 seconds, alarms went off everywhere. The supervisor hit the emergency shutdown, closing huge valves in the pipes rising from the seabed. This stopped oil and gas production and should have isolated the rig. But the blast had blown down fireproofed walls to the adjoining oil separation area, rupturing pipes and, as this footage taken just minutes after the explosion shows, starting an oil fire. The weakness of the firewalls was another legacy of Piper's inadequate design.
One might ask why the company had put in firewalls but had not put in blast walls. And one has to say that if you don't really analyse risks properly, if you don't really think the unthinkable, then all that putting in blast walls or whatever may represent is an awful lot of money, because they are costly, with no particular apparent advantage. So you're not inclined to spend money on things that you don't think are useful. You don't know how useful they're going to be unless you've really thought about it very thoroughly and deeply in advance.
At this point, it's probable only 2 men had been killed, and the situation was far from hopeless. Other rigs had faced similar oil fires and either put them out or evacuated the men. But Piper's emergency procedures simply collapsed. Control was centered around the rig's manager, who was supposed to coordinate firefighting and evacuation from the radio room.
Put out mayday.
Mayday, mayday, mayday. Explosion and fire on the oil rig, on the platform, and we're abandoning the rig.
But the radio room itself was damaged, and it appears that no attempt was made to use the public address system.
There's a fire. Mayday, mayday, mayday. We're abandoning the radio room. We're abandoning the radio room.
Transcripts of the maydays reveal that no indication was given to the emergency services of how the rig was to be abandoned. Worse still, no one told the men on board what to do. From what training they had received, the men were supposed to muster at their lifeboat stations and await instructions over the channel. But the fire stopped them from reaching the boats, so they assembled in the fireproofed accommodation block to await evacuation by helicopter. Over 100 men gathered in the galley area, just beneath the helideck. But the wind was blowing smoke and flames over the helideck, making landing impossible. The men were given no further instructions other than to wait. Although the accommodation block was gradually filling with smoke, at no point was there an organized attempt to lead them to safety. When the fire deluge system failed to start, 2 men bravely attempted to reach the vital diesel pumps that had been switched to manual. They never made it, and were never seen again. The emergency shutdown had stopped oil production on Piper, yet the oil fire continued to rage. It would eventually have burnt itself out, had it not been for the actions of adjoining rigs. Piper Alpha was at the centre of a network of rigs. Along with Piper, the Tartan and Claymore platforms pumped oil into the main onshore oil line. This pumping caused back pressure in Piper's oil line. It was forcing oil out of the ruptured pipes, fueling the fire on Piper. To prevent this backflow of oil, it was vital that the two other rigs stopped pumping immediately. 22 miles away, Claymore heard the first mayday.
You trying Piper?
Communications between the platforms had been knocked out in the explosion, yet the manager of Claymore continued to pump oil, believing that the situation was most likely under control.
We just got a second mayday. Big explosion. They might have lost the radio room and all.
Stand by vessel Nautica.
Proceed to Piper. See if there's anything they need.
The manager tried to contact Occidental's control centre on shore, meanwhile continuing oil production.
There's been an explosion on Piper and fire on the west side. There's a lot of black smoke blowing over the heli deck.
It sounds like an oil fire. Look, if it's a big one, Piper's lines are going to fail. I think we should shut down.
Is Piper shut down?
Yeah, they have.
How's the pressure on the line?
Yeah, it's holding up all right.
Don't shut down.
Meanwhile, the Tartan rig, only 12 miles away, in spite of hearing the maydays and seeing flames on the horizon, also continued to pump oil. The manager had received approval for this decision from the superior in Aberdeen.
There's always a potential conflict between production and safety. The revenue on a daily basis of an offshore platform can be very considerable indeed. When you shut a platform down, it's a difficult matter to restart it. It may take you 2 or 3 days to get back up to full, proper production. So it's not a decision you lightly take. Unless you give an OIM the authority to take a difficult decision in that situation without fear of subsequently being blamed, then people will delay, they will be inhibited, they will wait too long, and things can get much worse.
The oil spewing from the shattered pipes on Piper heated up something far more hazardous. There were huge gas lines also coming in from the adjoining rigs. These metre-wide pipes ran for miles and contained thousands of tons of highly pressurized flammable gas. The dangers were well known to Occidental's management. They had commissioned a report 2 years earlier which warned these pipelines, especially the gas pipelines, would take hours to depressurize because of their capacity. This could result in a high-pressure gas fire on the cellar deck that would be virtually impossible to fight. Yet nothing had been done either to protect or strengthen the pipelines. At 20 past 10, the Tartan gas pipeline melted and burst. Pipe every second, 1.5 times the entire UK gas consumption in an area just 75 metres square. Yet even this did not seal the fate of those on board. Such was the efficiency of the fire cladding on the accommodation block that most of the men were still alive, although increasingly overcome by smoke. Some took matters into their own hands, found their way down through the accommodation block, and although they'd been told that it would mean certain death, made the 10-story jump into the sea. The second explosion knocked out the telephone link between Claymore and Occidental's onshore control centre.
That's gone now.
Can we shut down now?
I need to talk to the emergency centre. Let's try and get them on the satellite system.
We should shut down.
Theros engaged in firefighting
other vessels are proceeding. Other casualties sighted on the drill floor of Piper anticipate very high casualties. Believe casualties still on board platform.
This is Claymore. Do you read? Over.
You can see the bloody fire from here. We really should shut down right now.
Their fire pumps should be coping. I'm still trying to reach the centre.
Look, they just told us. There's men in the water. They've abandoned the bloody rig. What more do you want?
ECC, do you read? This is Claymore. Over.
Although he repeatedly asked to shut down, the operator deferred to the seniority of his manager, and the oil continued to flow. Yet there was still one last route of escape, other than jumping into the sea. The Pharos, a gigantic safety vessel, had been built by Occidental precisely to deal with emergencies on their rigs. By pure chance, it was anchored that day close to Piper Alpha. It should have been a godsend. But having manoeuvred up to the rig, Pharos turned on its fire hoses too fast, tripped out the system, and wasted 10 minutes getting them restarted. Worse still, the extendable gangway proved painfully slow. It took 5 minutes to move 2 feet. So to extend to its full 30 meters took over an hour. At 10:50, they ran out of time. A second gas pipeline burst, containing thousands of tons of gas under enormous pressure. The intense heat drove the Pharos back, and from then on, the crew could only witness as the platform slowly melted and collapsed. The manager on Claymore had finally raised Occidental's onshore management.
No figures as yet. I don't know. No.
It's got really bad. Ask him if we can shut down.
Yeah, I'll do that.
Ask him!
What's happening?
There's another explosion. Just ask him if we should shut down.
All right, shut it down.
What's your status out there?
We're still online.
You what?
Prepare for controlled shutdown of MOL. I repeat, prepare for controlled shutdown of MOL.
Shut down now. Low down the gas line to Piper. Get hold of Tartan and tell them to shut down too.
If Claymore and Tartan had shut down oil production when they'd heard the first maydays, it might well have significantly reduced the fire threatening the gas pipes on Piper Alpha, at least delaying their rupture, if not preventing it. After withstanding the intense heat for over an hour, the accommodation block finally slid into the sea, and most of the rig fell after it. Of the 226 men who had been on board Piper Alpha, 166 were dead. One more died later in hospital. Only 61 men survived, almost all because they had decided to ignore what little training they had been given and jumped from the burning rig.
The escape was we managed to get outside after about an hour, going about the accommodation. We get out and into a fab shop. When the rig started tilting over. The fab shop tilted over, and believe it or not, the jib of a crane, you know, toppled, and that made a bridge, you know, that we could get along to the edge and jump into the water from there.
How far did you have to jump?
About 100 feet.
Could you give us some idea of the sort of thoughts that were going through your mind doing that?
You know, you think, you know, there was 3 occasions when trapped in the accommodation, you thought it was all over. When we got outside and couldn't get to over to the rig, you know, over to the side, we were trapped in this fab shop and there was things flying about and hitting you, and at one stage I got trapped and never got hurt. I don't know how, you know, big heavy steel moved right up to me and never, well, touched me, but never broke anything. So you thought you'd had it then, and when you went to the water you thought you'd had it then. It was just horrendous, you know.
When the Grampian police flew out to the location of Piper Alpha, this is all that was left. Ironically, it was part of the drilling deck, supposedly the most dangerous area, at the opposite end of the accommodation block. Three-quarters of the original platform had disappeared. The giant gas fires had generated temperatures over 1,000 degrees centigrade, literally melting the legs from under the platform. The management of Occidental, including Chief Executive Armand Hammer, were adamant that their safety record was impeccable.
I think we have taken every precaution we know how. You must remember this is the first time in 12 years that we've had a casualty on any of our rigs in the North Sea.
In fact, an oil worker had been killed on Piper Alpha 4 years earlier. The exhaustive public inquiry into the disaster, held under Lord Cullen, eventually described Occidental's approach to safety as superficial. It cited a catalogue of errors and shortcomings, many of which were relevant to other North Sea operators.
I wouldn't put it above or below other disasters. There is actually an awful sameness about these incidents. They're nearly always characterized by lack of forethought and lack of analysis, and nearly always the problem comes down to poor management. It's not just due to one particular person not following a procedure or doing something wrong. You always come back to the fact that things are sloppy and ill-organised and unsystematic right from the top of the company downwards.
In the wake of the Cullen inquiry, the oil companies spent billions redesigning platforms and improving safety. Many rigs were fitted with seabed shut-off valves in their gas and oil lines. Lifeboat entry points were brought inside the accommodation blocks, and these in turn were reinforced with better fire and smoke protection. On top of this, the overall regulatory responsibility was taken away from the Department of Energy and handed to the Health and Safety Executive, which Lord Cullen felt was more suited to the task.
North Sea operations maybe have another 20 or 30 years to run. The hope has to be that there will never be another major accident of that sort, and I think there's a reasonable expectation that there won't be, because so much has been learned from it. I mean, Piper Alpha was a terrible tragedy, but if we learn the lessons from it and put them into effect, then at least future events will have been prevented.
But if improvements have been made, it took the lives of 167 men to bring them about. Yet there are still at least 10 gas escapes a year, as large as the one which triggered the Piper Alpha disaster. Occidental destroyed the twisted remains of Piper Alpha within a year. They have since sold off their interests and left the North Sea.
Will you go back to work offshore?
No, I don't think so. No.
Well, I think you saw there the various aspects of this incident. It was a complete disaster. But I think towards the end there, they paid a bit more attention to the management structure of Occidental. And you could see that from even the lower level, the operating managers who was frightened to shut down the plant that was supplying the oil to the fire, things like that, all the way up to the boss, really, Armand Hammer. You can see that they actually had quite a poor knowledge of safety. This might have been back in 1988, but there was still an awful lot of techniques around for ensuring safe operation. There really were. For example, Occidental really didn't understand the full range of hazards. They converted that rig from an oil rig to a gas rig and hadn't done any real hazard studies to find out what the potential hazards were. The hazards change. You've got different hazards for an oil rig, different hazards for a gas rig. They put firewalls in, not blast walls. They spent an awful lot of money putting the wrong equipment in because they didn't identify the potential hazards. Nowadays, of course, anybody in a similar situation to that would do a hazard. We will do one in a week or two's time. I'll show you how to do hazards. We'll do it as part of this course. And the question is, if not, if you didn't have a look, how could you understand the risks? If you don't identify the hazards, and of course, that platforms in the North Sea then weren't subject to hazards. I think you heard towards the end of it, there was actually a change. Before then, the Department of Energy used to handle all the safety on these offshore rigs, and they didn't used to handle it very well. But after that, they handed it over to the HSC, that's the Health and Safety Executive in the UK, which I talked about last week. And they are much more vigorous and quite useful with that sort of thing. So, ask yourself, were all the hazards properly considered in the design? So you had the accommodation block fire resistance versus smoke resistance. They didn't have the proper ability to isolate platforms from the fuel sources, so you still had the other oil rigs pumping oil, and the back pressure was coming back through Piper Alpha. Ability to isolate platform from the fuel source, robustness of the shut-off systems. Yeah, they did all this after the event. Before the event, they didn't have this. So ask yourself this question: which design change from oil to gas contributed to the incident? And of course, not just the incident, but we're talking about consequences here. What happens after that? So they introduced a significant gas and leak explosion risk. And the gas pipelines were within the oil fire zone as well. And of course, we had the proximity of the major hazards to personnel. Well, pretty much on an offshore platform, that's kind of a given. You can't get away from that. Although nowadays they will put the accommodation blocks as far away as possible and put as many layers of protection between the hazardous areas and the accommodation blocks nowadays. So there's a lot of design factors involved, and I think the film actually covered most of the ones that we're interested in quite well. So there's the layers of protection, hardware. What physical layers of protection failed or were compromised? Well, we've got that pressure relief valve for a start off. The open ends weren't properly sealed. And also the fact that we'll get the permit to work in a moment, and also the fire water system, which was disabled as a routine practice.
Which was a manual.
Yes, not manual, that's right. Normally, we switched on automatic, but when there was divers down, swimming around, if those pumps came on automatically, the divers would get drawn into the intake for the pumps, so you switched them on to manual. So if you needed the fire pumps when there was divers down, you could tell the divers to get clear and then start the pumps. It's not really a very good way of doing it, is it? Seriously. The trouble is, once an incident starts, people say, well, why haven't the fire pumps started? Well, they're on manual. How do you get there? Well, you can't, because there's a fire. That's hardware. Certainly other hardware problems. Software. What key software systems do? Well, this was the key one at the very start. there was a permit to work system, but like I said earlier on, it had been reduced to a tick box mentality. So they had a permit to work for the pump, and it was being taken off for maintenance. Somebody else took the pressure relief valve off, and they put a separate form in, and the two forms got parted. So later on that night, when the guy decided, well, this pump's stopped, we can't get it restarted, we'll start the old one, because they haven't done any maintenance on it yet, and looked at the permit to work, didn't realise the pressure relief valve was missing. So there you go, coordination. Yeah, so some key points there. Nowadays, what they would do is have a lockout tagout system. Have you heard of that before? Yeah, Lotto, yeah. So on the main switchboard for that pump, the starter, whoever took the pressure relief valve would put their own lock on that, and whoever stopped it for maintenance would put their lock. So you'd have two locks, as well as the paperwork, of course. It's fair enough. So if somebody tried to start something in an emergency, there'd be two, you'd get one lock off, because you'd say, okay, I've revoked the maintenance one, but there'd still be another lock on there, which would stop you. So there was lack of communication. I mean, you've got different people working, different shifts coming on, going off. So obviously the people that were working that night weren't fully aware of what had been done to that piece of equipment earlier on in the day. Human factors. Well, human factors are all around us, and quite a lot of accidents occur because of human factors. So there were certain human factors here which contributed to the incident. There wasn't any proper training in the permit to work system. It was just a bit of paper that you tick and hand it in somewhere, you put it in a big box. It was never seen again, type of thing. People do that and forget that it's there for a reason. There's an actual reason for it. It's not just a box ticking exercise. And of course you saw that incident where the guy wanted to shut down the oil on the next platform, but he was he wouldn't, because his boss was dithering. He wouldn't shut the oil down because he was frightened of him. He wouldn't shut the oil down until he talked to the big boss ashore. You know, there was no clear delegation of authority. Whereas nowadays, if you're the first one on the scene, you make the decisions, you shut it down, and they can't touch you for it nowadays. So there's priority of production over risk management and emergency response. So we saw that kind of indecision and delay in the film. That was quite key. If they'd shut their oil pumps down at the very start of the incident, like the guy in the movie said, you would have still had a problem, but it would not have been as severe. So I think nowadays they've got that sort of attitude. If you had an explosion, anything that's potentially contributing to it gets shut down. They've also got C-bottom ESD valves, emergency shutdown valves, so they can actually shut them down as well, so there's no chance of any back pressure going back to the brake. So the safety chain. Like I said, there's something that they didn't do, especially when they changed it from oil to gas. They certainly didn't actually do any HAZOP on it. No identification of the new hazards that were associated with it. And of course, once you've got these hazards, you need to have assessment of the risks. Management of the hazards and the risk is quite important. And there's a few things there you might need to do with it. Elimination or reduction by better design. Minimization through control and through procedures. And mitigation through response. So all these various factors can't be done until you realise what the hazards were. And of course, Occidental didn't know what those hazards were. They had an inkling of it, but they weren't prepared to do anything about it. Okay. That's it. I'll see you in a couple of weeks' time. I think with you, I am doing a lecture on HAZOP, and then we'll do a HAZOP workshop. And then you go away in groups and do a bit of work and you get assessed on it. Okay? I think the schedule's on Blackboard. I haven't had a look at it recently. Okay.